Welcome into the discussion about connected and static routes. Now, I could have drawn up a big, long, boring slideshow about connected and static routes, but this is one of these subjects that is easier just to show you how it works. And so, as a result, I have built a very small network in GNS3. Now, if you happen to be playing along at home, I have included the configurations for all three of my routers, Jake, Jane, and Roxy, in the work files for this particular section. But essentially, each of the three routers have three networks defined on loopbacks, 10.1.1.0, 10.1.2.0, and 10.1.3.0, and so on and so forth. You see it laid out there. And each of the routers are connected via a point-to-point link with only two IPs on the link. It's a /30 network. So now we can just dive right in. We'll look at this first router named Jake over here. We'll do show IP route, and you'll notice that when we investigate the routing table, we see a bunch of routes that have a code of C, and C is connected, and quite simply, these are the networks that are directly connected to this router. These are the networks that this router knows exists because it's directly connected to them. And obviously it knows the subnet mask because it has to be configured properly on the interface facing these networks. Now, obviously for these 10.1 networks on this router, we're using loopback interfaces, but in an actual production network, you could use switch virtual interfaces or VLAN interfaces or actual router interfaces, depending on the platform you're using. And essentially, every network that is defined on an interface appears in the routing table as a connected network. The same holds true for the other two routers. If we do show IP route on Jane over here, we have the same connected networks, except Jane has one more because, as you'll recall, Jane is connected to both Jake and Roxy. If we go over to Roxy, we do show IP route. It knows about all of the connected networks here, and it only knows about the point-to-point link between Roxy and Jane. Now, since these are directly connected networks, I can ping any of the hosts on those networks. For example, one of my connected networks is 192.168.1.0/30, or more specifically, 192.168.1.4/30, since that's the interface on this guy. So if we do show IP interface brief, we see that this router has the IP of .6, so I should be able to ping directly 192.168.1.5. And because this is a directly connected network, I do not have to depend on any other routes, static or dynamic, to get to that .5. I can also examine the ARP table on this router, and you'll see that I've directly learned the .5 address from this device by virtue of the fact that it's on the same network, and I can just send out an ARP request saying, hey, give me your MAC address. Now, perhaps the more astute among you may have realized that Roxy doesn't know about any of the networks on the Jane router, and Jane doesn't know about any of the networks on the Jake router. None of these routers know about any of these other networks. And under normal circumstances, and later in this course as well, this is where a dynamic routing protocol would come in. However, since we're studying static routes in this particular video, we'll just set up static routes across all of these routers so that they all know how to get to all of the other networks. And I'll demonstrate this on one of the routers, and then I'll pause the video so that you don't have to see me enter the same commands on all three routers. Now, I've built these networks in such a way that I can also demonstrate summarization in this same lab as I'm building the static routes. For example, we're over here on Jake. We can go over to the Jake router, and we can tell the Jake router any networks that begin with 10.2.0.0/22 or 10.3.0.0/22 can be found beyond the Jane router. So let's go build those two static routes in the Jake router. So we go into config mode, and we're going to do IP route. You have to type out the word route. And there are a few other commands you can do in the IP route command, but in our case, we're just going to enter a destination prefix. So in this case, the destination prefix is 10.2.0.0. So 10.2.0.0. Now, I could enter each of these networks individually. In this case, I'd be entering 10.2.1.0 or 10.2.2.0, but we're going to demonstrate summarization. So now that we've entered the destination prefix, we have to enter the destination prefix mask. In this case, it's 255.255.252.0. And next, we have to tell it where to send this traffic. Now we can specify an interface, i.e. just fast Ethernet 01, send all of this traffic out fast Ethernet 01, regardless of what IP address happens to be there. And if you have a dynamic IP address, like a DHCP router connected to an internet provider, that's probably the best way to handle it. In this case, we don't, so I'm going to specify the forwarding router's address. So I'm going to say take all of this traffic and hand it to 192.168.1.2. So in this case, 192.168.1.2. So what we've done is we've said IP route, we're going to set up a static route to this network with this subnet mask to that router. If we hit enter, now we can show IP route over here. And now you notice that 10.0.0.0/8 is variably subnetted because we are now using VLSM on this router. We have a /22 as well as a bunch of /24 networks. Now I should be able to go ping 10.2.1.1, which is the loopback address on the Jane router, and it's shipped over to the Jane router, and the pings come back. Now some of you might think that the traffic shouldn't come back, and I'll explain why some of you might think that, and show you that it does indeed break under certain circumstances in the next video.